Hi, everyone. Thanks for joining. Tonight, I'm going to talk about cave survey data and how we can work with it as effectively as possible using some very cheap or free, easy to access tools. There is a lot to cover in this presentation, but I'll try to keep it tangible so you get as much benefit as possible from it. We'll go through a few slides here at the beginning, and then we'll dive into settings in TopoDroid that give us the data outputs. We'll look at what those export options are, the settings. We'll take a look at how those export options can take us from TopoDroid directly into the Cave Survey software. And then we'll wrap up with a demo of how to use generative AI models, specifically ChatGPT and Anthropic, Claude Sonnet, to do some data conversions. And we'll also generate some Python script. We're not going to go deeply into any of these topics since there are so many here. But if you have questions along the way, feel free to write them into the chat or go ahead and unmute yourself. All right. So in that vein, we're all here for one reason, because we care deeply about caving. I'm grateful that you're here. I'll do my best to make it worth your time, because the next time that you are out there caving, my hope is that you can take something away from this presentation to help you push a little bit farther, explore a little bit smarter, map something amazing with a bit more ease. So let's look to see where we've come from in this digital cave surveying series and where we're going. There have been two presentations so far. The first one was March 27th. Bert Ashbrook talked about the differences between paper and digital sketch. And some of the key takeaways that he had were that digital sketching is more expensive, but it offers a lot more efficiency than legacy sketch. Bert recommends that you do get good with paper sketching first before transitioning to digital sketch. The transfer of data from collection device to tablet is automatic, and that eliminates a whole bunch of transcription errors. It makes things a whole lot easier. Bert focused on that in his talk. He also talked about digital data archiving, and he noted that different projects have different preferences. There's a lot more in Bert's presentation. So if you haven't seen it already or have forgotten some of those details, then head over to the Survey and Cartography section's YouTube page and give it another watch. The second presentation in the series was April 9th. Derek Bristol also talked about digital and paper sketching. And he also talked about that there are a number of digital instruments, and he talked a little bit about their history. He mentioned that TopoDroid is usually the software of choice. There's a huge benefit of digital sketching in that you'll never run out of space, as opposed to paper sketching when you can go off the page. Echoing Bert, Derek said that sketch quality depends on skill, not on the device or the paper and the pencil, and that digital can result in much more efficient surveys, especially in challenging environments. And so just like Bert's presentation, Derek's is also on the SACS YouTube page, and you can head over there and give it a watch or share it with others. So that brings us to this evening. I'm going to spend the bulk of the time talking about data. Next time out on May 8th, Bo's going to talk about his transition from paper to digital. Christian's going to talk on May 22nd about sketching in TopoDroid for Therion. June 5th, Dane will demonstrate some advanced TopoDroid tips and tricks. And John will wrap up this series on June 19th, the week before convention, with discussion of project planning and management. Also of note, there will be at least a few presentations on digital cave surveying and sketch at the NSS convention this summer in New York. So if you're there, stop by for those talks. All right, so let's get into it. Let's dive into some more details of cave survey with digital. We collect the data with a survey device, and via Bluetooth, it comes into TopoDroid on the tablet, like we're seeing here. The legacy steps of reading the numbers from the device, whether it's a digital device or an analog, then writing them down on paper, plotting them to scale. Earlier than that, not plotting them to scale, Those days are gone if we're using digital. Digital survey eliminates those steps entirely. So thanks to Marco Corvi and a number of others who have written tools like TopoDroid and others, the survey stations get plotted where they should be in the plan and profile views. And then we can focus on sketching the cave. So Bert spent a lot of time on sketching in his presentation. Derek did as well. We're going to hear about sketching from Bo, Christian, Dane, and in some capacity from John as well. And you're going to hear it from me this evening. Even though this series is called Digital Survey, really the fundamental aspect of this is sketching, right? It's drawing the cave in 2D. So digital survey really allows us to focus on sketch. And so for me anyway, I can sketch a whole lot longer when I'm in the cave, because the hardest part of keeping the book, at least for me, is writing down the numbers, listening closely, making sure I've written them down correctly, plotting the survey stations, making sure that those are correct. I don't have to worry about that anymore with digital sketch. It makes it a whole lot easier. And then with splays, the walls are exactly where they really are. The features in the cave are exactly where they really are. Cross sections the same way. And so what that leads to is really the ability to go from in-cave sketch, which if you do it well, it should be map ready, to a cleaned up converted sketch that we can hand over to the cartographer. And you, as the digital surveyor and sketcher, you have the survey notes, you have the sketches in your tablet. And if you keep working in that area of the cave, then you know where the leads are, you have all the data, you can really just pick up very easily, or you can get that data from somebody else or share it with somebody else very, very easily, way easier than with paper sketch. And that just makes the overall survey process much, much more efficient. And so again, a lot of what we had to worry about previously using legacy survey techniques, especially what we did in the cave on paper, it's taken care of. But outside the cave, when we're done collecting the data, other than those sketches, really they should be close to ready to use as maps. What's not a lot different from legacy survey is the data part of it. With legacy survey, software was created based on manual entry. And with digital survey, while we don't have to do manual entry, we're still using those software packages. And so let's go a little bit now into TopoDroid about what it's doing to allow us to export the data. Again, we're going to talk specifically about TopoDroid settings. They can be configured in a variety of ways. Personally, I use the 3-4 site leg shots, left, right, up, down, splays, and a back sight. And that's actually done with a stations policy with 2 elements in it. And we'll look at that in a minute. So here's the setting in TopoDroid that shows 3 forward shots. And that's what is required, at least in this case, to establish the survey leg. And the survey leg, the equivalent in legacy survey would just be the front sight shot in this particular case. To get these particular settings in TopoDroid, we click the 3 dots in the top right. That takes us to the settings. And then another screen pops up. Then we can go to the stations policy. And we can see that here I've got that forward leg. Again, this is 3 shots. They should be as close to identical as possible. In this case, they have to be less than, I think, half a degree in the way that I have it set, which in TopoDroid, you can control that setting. And as I said earlier, I collect the forward leg, and then using the splays setting, the second part of that stations policy, then the next 4 shots are left, right, up, and down. And then the actual splays, and this can be any number of splays. And then the very last shot I do is, or have the instrument person do, is the back sight to the previous station. Now, you might have noticed that there's a timing difference between the collection of that front sight and back sight. The front sight for which we just collected a back sight was collected at that point, essentially 2 stations ago, right? It's the station that's literally behind us. What I'm describing here really has to do with the recorded data. But there's nothing stopping you from doing front and back site comparisons at any time during the survey. Just make sure you're noting what's what and that you really are doing front and back sites. And then, look at those numbers to make sure that they're close. If they're not, could be an indication of magnetic interference or the battery is running down, instrument failure, could be anything, right? So just make sure you're collecting front and back site. And again, I found the most flexibility as well as efficiency with the way that I do the surveys is this station's policy of forward leg and splays. There are additional options. And so you can use a different stations policy, like the ones that are listed here. You could put splays first. You could do splays and then a backward leg, and so on. But whatever you need to do for your particular survey, you've got a bunch of options right there. All right, we're talking about this because the settings that we have in TopoDroid, of course, lead to the data essentially that we're going to collect, right? So let's go back into a little bit of data and start to look at what the data are doing. We can get the data from TopoDroid. We go into survey info and then click the three dots in the top right. And that takes us to the landing page with the basic information about the survey. We click the three dots again, and then we get into the export options. And there are many in here in TopoDroid, and they can be confusing. If you're using one particular cave survey reduction software, then you can select that one and focus on it all the time. But if you're involved in multiple projects, then you might have to become familiar with multiple export options. Let's take a look at these. There are a lot of options. We're going to look a little bit further into these that I have highlighted here: Compass, Cervex, Therion, Walls, and the CSV. Toward the end, we'll do some exercises with the generative large language models in Python with CSV and Walls. So Therion export produces a .th file. Therion is going to be talked about in the call on May 22nd with Christian. He's going to do a deep dive there, so I won't spend a lot of time on it. But you really need to get two files out of Therion, the .th and the .th2. And then that has the scraps and the data in it. And the scraps are essentially the sketches that can be assembled together to make a map. Compass also has to export a .dat file that has the data in it, and then the .plt file, which is a plot. Walls is only a .srv file, and Walls itself does the visualization. Cervex, Tunnel, I've never used Tunnel. I've read about it a little bit. The CSV file, we'll look at that one a little bit more, tab separated. And then the TDX file, exporting that allows us to bring the data back in. So that's just TopoDroid X, essentially, is the version that we use. Let's look a little bit more at Therion now. So there are some requirements for Therion, and really when Marco Corvi was creating TopoDroid, he was using Therion and making sure that TopoDroid and Therion were talking to each other. So the combination of those two software packages together is really the high watermark of digital survey. There are some folks who believe that the map visual quality of Therion is not the same as the kind of work we would do in, say, Illustrator or something else, but there's nothing stopping somebody from going from Therion to Illustrator and making the maps look pretty. So for those who want to be really efficient about it, the combo of TopoDroid and Therion it's just fantastic. And so these are just the instructions for how to get the information out: survey info, menu, three dots, export, choose Therion, and so on. And then in the export screen, there's going to be some options like including the left, right, up, down, comments, and other things. The data, when they come out, they look like this. Might be hard to look at, but essentially it's just an ASCII file with a bunch of information on it in a particular sequence and syntax. And so again, May 22nd, Christian's going to do a much deeper dive into Therion and sketching in TopoDroid. Using Compass, you get the .dat file, comes out. Again, the same thing: survey info, export, Compass. There are some options. and the export will generate that .dat file. And it will be openable directly in Compass. You'll be able to go straight from TopoDroid to Compass, and it should be clean. Should work. And then there on the left, there's the raw DAT file. And then on the right, those are what those data look like in Compass. And this set of data right here cleanly and generated the map cleanly, as you can see here, including displays. Those are display shots, those extra lines sticking off there. Walls, SRV, mainly that's just a simplistic abbreviation of survey file. Yeah, and so similar approach to export. Yeah, look at the data here. Unlike the .dat or .th file, you can't go straight into walls and just open a .srv file. You have to also have a project file. Therion has a similar kind of a thing where you're basically having a compiler, but with walls, you need to have that project file. So if you export the .srv and try to open it in walls, you won't get anywhere. You'll have to, again, create the project. Once you do that, though, then very cleanly, you should be able to go and plot the data. And you can see that this line plot looks identical to what we saw from Compass. We would have seen the same thing if I had done that for Therion. Servex, the tool that this would go into is Cavern. I'm pretty sure you can also directly import Servex into Caveware. I've tried that and it works pretty well. Visualization of Servex files in Avon. And then Servex was actually the foundation of Therion. And so they talk to each other pretty well, but not 100%. Or at least Servex files can go into Therion. But got a similar format as the other ones. There's a syntax. There's some preamble information. There's shot information, LRUDs, etc., etc. So those are all the main options. There's also the CSV, and same thing, you can export it, you get some options. This is really good if you are not going to be going into Compass, or at least not yet, or not into Walls or Cavern or Therion or wherever initially, and you want to do something else with the data. You can export it as a CSV, or as we saw earlier, a tab separated file. And then here's an example of the CSV. This one is a little bit more complicated, but it's also very thorough. So because of that, it's easier to work with accurately, although I wouldn't want to do it manually. Like, highly encourage this to be done with Python script or with generative AI. Although you can work with it manually because you can open it in a text editor or in Excel or something else like that. We're going to now move on to the next one. So yeah, okay. So again, it's pretty complex to work with the CSV file, but if we use this thing called vibe coding, not sure if anybody's heard of this before, but it is a relatively new terminology. And essentially it's using generative AI to create code. And people have been doing it for a while, works really, really, really well. Let's look at the very last export that we need to do, right? So to this point, we've been exporting data, but that's not all that we need, is it? Right? We also need this. We need to be able to get that sketch into wherever we're going. Now, if it's Therion, then we're going to export Therion. It's going to go out as that th2 file and the scraps and everything. But for the others, Compass and Walls in particular, the export we want to use is the SVG. PDF is an option, but PDF doesn't bring all the information. The SVG does. And so there on the left is a sketch exported as an SVG, on the right into Illustrator where it can be worked on, modified. Or it could go into another scalable vector package like Inkscape. GIMP is another one that people use. It works pretty well. So that's the last export. So this is just a bit of a recap of the section that we've just gone through here, showing us file type and the required fields, notes, things to be aware of, and what the visualization and outputs look like. Again, if you're using one of these, walls or compass, then, get good with that particular process from the settings that you put into TopoDroid, collecting your data, knowing what to expect when the data and the SVG come out. You're using more of these, then of course, just, you spend more time and be familiar with those. TopoDroid is a very powerful tool. In addition to the software, we really need to make some considerations about other aspects of the data. And these are going to depend on the particular cave project, of course. But if the cave is of any length, it's going to take some time to survey, possibly years. So we're going to want to know the declination, which is the change in magnetic north over time. We also might need to keep in mind if the data will be involved in GIS, which is related to declination, of course, but also position of the cave entrances and the position of each of the survey stations. We also want to be considering the data accuracy, the survey device accuracy, and reliability. For some projects, LRUDs would be an important consideration. This was discussed in Derek's presentation about the value and importance of collecting left, right, up, down. If the entire cave is being surveyed digitally, then there's probably no need for it. But if it's a combination of legacy and digital, and there is a record-keeping approach that expects left, right, up, down, well, then in your survey using digital, you're going to have to make accommodation for that. So as I mentioned earlier, we can use displays to collect the LRUDs, and we can actually tick a box or make a note inside TopoDroid when we're collecting that information about what's what. If we're patient enough, we can actually literally paint the entire surface of the inside of the cave and all the features, and create a 3D point cloud. And so again, if we're all digital, then having LRUDs, probably isn't that important. And on that point, someday, this digital survey could become the legacy. Some of you might have seen this movie, Prometheus. I've got a short clip of it here. Prometheus, we are now mapping. So this is, of course, not what we do right now. And, I've been using that terminology of legacy versus digital. There are a lot of tools out there that are being used at the moment, and presentations on them. And there's going to be some presentations at the convention again, where people take Cavetron in the cave and do this kind of thing, but they have to walk along manually instead of throwing some orbs up into the air and collecting the information. So good to keep things in perspective. All right. We just need to make sure that we know what syntax or format the data need to be in. We need to understand the error calculation and what that means. If we're doing GIS, again, we need to keep track of that. And so these are aspects that aren't that different from legacy cave survey. Again, what we've already talked about is what's different is that we don't have to manually enter the data. And because we're using computers for these things, we can automate some or most of these steps. All right, so we have been quite broad to this point. Let's drill down a bit more and we'll look at some CSV data. I'm going to share my screen here in a little bit, but before we do that, let's go and talk about this guy. This is Andre Karpathy. And this might feel like a major turn from TopoDroid and looking at the data, but this is a really important thing to understand. I want folks to recognize that you have the power to completely control what you do with the data And a lot of that comes from these generative AI models. Andre Karpathy is one of the founders of OpenAI, one of the co-founders. And so recently he came up with this term, vibe coding. And really, again, folks have been doing this for a while using GitHub and then also GitHub Copilot and Continue in VS Code, Visual Studio Code. So this is somebody who is responsible for this huge AI transition that we're going through right now. And he's the one who coined this terminology. There's a new kind of coding I call vibe coding, where you fully give into the vibes, embrace exponentials, forget the code even exists. It's possible because the LLMs are getting too good. And he described some things that he's doing here. The code grows beyond my usual comprehension. I'd have to really read through it for a while if he was doing it in the legacy way. Sometimes the LLMs can't fix the bug or just work around it and look for another way to get through it. And then if there are errors, copy those errors back into the large language model and ask it to generate it again. And so this is coming from, again, one of the people at OpenAI who helped change our history, right, forever. Really the trajectory of humans. There's a number of folks on the call. I don't know how many of you are using ChatGPT or Anthropic Claude or some of the others, Claude Sonnet, Anthropic, but I highly encourage you to. It is not going away, and it is one of the things, kind of like digital survey, that makes our lives easier and I think better to enjoy caving with. Something to keep in mind when we're doing this, before we go into what we would need to do this, is that any code that's coming out of these generative AI tools can't be copyrighted, right? And so as long as we're working basically in the public domain, then we're fine. And so for that reason, it's not used, this approach is not used for, or at least not very much, for productive software products. But if it's internal use, personal use, like we're doing with caves, essentially public domain, then we can go nuts with this thing, and we really should. What is of importance here to keep in mind, since I've taken us down this rabbit hole, I want to, make sure that we do a rabbit hole through trip here. We'll come back up in a minute. What's really important is the data protection piece, especially of sensitive information. And this is a really, really important thing. With caving, we probably don't have a whole lot to worry about with that. We just need to make sure we're not violating any landowner or property manager contracts or MOUs or agreements, right? But the fact is that most, if not all, of cave survey data, it just really isn't useful to anyone when it's out of context, right? So like a set of survey data just doesn't mean anything unless it's part of, the whole picture. And so, the things to be really careful about are personal information about people and financial data. Discourage that kind of thing to be used in these tools. So, okay, let's come back to the surface now, out of that rabbit hole. Let's go rock and roll with some vibe coding for a little bit to set us up for some hands-on work. Okay, so to do this thing, we're going to need a few things, right? And now we're back to what tools are we using to work with our cave survey data. We need an IDE, integrated development environment. This is Visual Studio Code. It's free. It's easy to use once you start getting into it, and especially if you have that large language model sitting next to you and you can ask it questions. It's called Visual Studio Code in Windows and Linux. If you use that, it's just called Code. Same thing if you're in Apple, VS Code, or you can use Apple Xcode. And there's other IDEs out there as well. And then there's a tool that you can use called Brackets that I use to look at files. It doesn't work like an IDE, but it's really easy to look at a wide range of ASCII-based formats. You can also use VS Code to view and edit text. That would keep everything in one place. You'll see why in a minute, why it's important to be able to do that, whether it's in VS Code or in Brackets or even in Notepad. And then the next thing we're going to need is access to large language model. Here's ChatGPT, Claude. There are like 3 dozen or more of these things out there. If you're really into this stuff, then you can go and knock yourself out playing with them. If you want to focus and drill down on your cave survey data or some other specific application you want to work on, then ChatGPT 4, maybe 4.5, 4.5 as well, and Claude Sonnet 3.7. That's it. And those are the most popular, most reliable, most effective ones. You're hearing about minis, hearing about DeepSeek. If you want to do work with these things, then just skip all that noise and use Sonnet 3.7 or GPT-4 Omni or 4.5. And then you can also just Google these things to see, and see the performance tables of all these different large language models. And, you're going to see a bunch of other names on there, and, they're going to claim that they're all great and stuff like that. But, there's a combination of reliability and effectiveness and ability to have conversations and do planning and do coding and all of those things. These two are the best. Okay, we're also going to need some kind of a syntax or format. I'm just providing an example of maybe one kind of syntax that we would want. This is going to be for walls. You might have another one that would be for Therion or, Compass or, whatever. So we need the IDE, we need the large language model, we need whatever we're going to use as the template. We're going to need some data. That is the data export from TopoDroid. So with this then, I am going to minimize this PowerPoint, and we'll start to throw in some prompts. I'll pull up some data. So we're going to go live demo now, no more PowerPoint slides. And if anyone has any questions while I'm making this little transition here, go ahead and just let me know, and or post them in the chat. Oh yeah, John, thanks for answering that question. Mark the shot is overlaid. Okay, cool. I did not know that. ChatGPT. And here is Claude. We'll put Claude right there. And then I'm going to go grab my folder. You guys are still, somebody let me know, you're still seeing ChatGPT, Walls Cave Survey Software, and Claude?
Yep.
Okay, great. Thank you. And let's go get the folder that's got some sample data in it. And I'm just going to go ahead and open this in bracket for now. We can open it in other things as well. Okay, and so this is bracket. It's the real thing here. And then let's go over and grab Visual Studio Code. Okay, here we go, blank. We'll start off there. All right. And then let me do one more prep over here on the side. And then we'll start to drill in. So let's go back over here. You might have noticed that I've got this ChatGPT page up here, and it says Walls Cave Survey Software, right? And so Walls is one of the things that I use. That's why it's here. But this is actually a GPT. And what I did here, this is actually one I've had for quite a while, is there's over here in the sidebar, if you haven't used ChatGPT or Claude, you can make your own or share with others what's called a retrieval augmented generation approach to accessing information, additional information. And this particular one, let's just throw this in here a little bit. Let's say, tell me about Walls Cave Survey Software. If I were to do this in a non retrieval augmented, or we can do it with Claude, a generation approach, then it's going to give me information that it has found on the internet. Okay, so it's going to go through its process. This one, however, is actually accessing the user manual. Okay, and so, and again, we can make either one of these do that, or both of them do that. But if you're going to use Walls, I would recommend that you would preload some of the files that you can get information from about Walls or Compass or whatever into one of these GPTs. And it's not that hard to do. You will have to spend a few minutes, working through it. And so I'll search for more information. It's searching the internet, and And it's referencing one of Derek's sites here, referencing another one. Okay, so this information it collected from the internet, whereas this information was collected from the user manual. Okay, and so I'm going to go with this one for now because we're going to ask it to convert CSV file into a wall-specific SRV file. Okay, so the way that we start by doing that, and let me pull this over here, is we need to tell it what we want to do. It is forgiving of typos and things. So if you miss some words, it's fine. And actually, just by kind of a show of hands, maybe just in the chat or something like that, can you all let me know if you guys have used large language models? Maybe a little bit about your experience while I'm typing, and you guys could also be typing and sharing about that. SRV file. I will provide a template and the raw CSV data. Here is the syntax file. Okay, and so we were just looking at that file here in brackets. Okay, that's our raw data. And then here's our template. Okay, and it's not going to get this first on the first pass. We're going to have to clean it up a little bit. So just so everybody's aware. By the way, if you've used these things before, you know that you need to do a shift enter. And that'll give you another line like this. So these tools, I mean, they're part of the world that we're living in right now, kind of like in the same way that the digital survey devices are, kind of like the way cars are, all of those kind of things. I mean, it's not, in that way, it's really not different from other kinds of technologies. It's just something that it's come on very quickly. And I do encourage folks to become very familiar with it because they're not going away. Okay, so that's the format, right? And then, okay, yeah, so looks like in the chat, yeah, there's a wide range of usage experiences. It just depends on what, personal preferences are. Yeah, I mean, there's, okay, where's brackets? We want to go back to, pull this thing over here so I can leave the screen open. And let me go get that example. Okay. Now I'm going to do the same thing. Now, yeah, let me go get that data. What I was going to say is that you can do this in a variety of ways. We could also, in the same way that the walls manual was uploaded, we could actually upload all of these as files and then have a conversation. But this is really the most efficient way to do it if we're not going to continue to refer back to those files again and again. All right, so here comes all of this data. Let's see. Yep. That's all the CSV data right there. And then the last thing that I'm going to have it do is I'm going to say, using your knowledge of walls from the walls manual, make sure the resulting SRV is properly formatted. Also, please look for coordinates. Let's say UTM coordinates or latitude, longitude, or other location identifiers. So what I'm going to do here is I'm going to tell it, if you find UTM or similar locations, stop the analysis and inform me. We need to keep a survey location private. And then the last thing we can say is, let me know if you have any questions. Right. Okay, all right. Request summary, use the CSV data you provided, convert it to an SRV file, apply proper walls SRV formatting, with directives, units, prefix, and that's the right format that would be in an SRV file. It's telling us it's going to look out for location information, that it's going to reference the template, and that the syntax follows walls formatting rules. Great. Okay, first thing, check for location data. It didn't find any. You're good to go, nothing needs to be redacted. Okay, so these are pretty good. ChatGPT 4 Omni 4.5, Claude, Sonnet 3.7, they're very good. You guys have probably all heard about hallucinations. And so what happens is that it will tell you something that it believes is real, which means that anything that come out of these things, you need to be skeptical about. Like anytime I see a message like this, you're good to go, nothing needs to be redacted, I'm like, okay, right. And so even though it really helps speed up our process in doing almost everything, take it with a grain of salt, right? Validate, make sure that we're, and so I actually know that there's no UTM coordinates because I know that data set. But just because I know it and it didn't detect it doesn't mean that we don't, want to go check for those kind of things. It's looking at the CSV format. It's building the SRV file. Okay, we're going to test this thing in a moment. All right, that looks pretty comprehensive. Okay, so what we'll do now, I'm going to copy this. I'm going to bring up walls. And this is really the, where the rubber hits the road. To convert that manually would have been really, really time consuming. If, we were working efficiently to get this thing done, then we would have done it in, much shorter time than I took to do it. Let's go make this new digital demos. We're going to do a finding. Let's just call this like test, I don't know, test 2 or something like that. Okay, test 2 project. Walls has a requirement for a title that is, now the project title can be longer. I'm still only going to make it this long. The survey file, make that feet, go okay. Let's add a new Booker survey in a minute. It has a requirement for a name and not counting the file extension, character limit of 8. Here is where we can use VS Code and let's just use VS Code, or brackets. So we're in the right folder right here. I'm going to go ahead and just make a new file. And we're going to call this one test002.srv. And I'm just going to paste in what we just copied out, what was just generated by ChatGPT. And then a Control S to save that file. Okay. And so now if I come over here and I say I want to add a new Booker survey, then here's the survey file. Let's see, compile options. We'll look at that in a minute. Here's feet. Okay, I'm just going to say test002. I'm going to browse for it. There it is. If there's an error in the naming, it's going to tell me right now. So hopefully that means it's okay. Check the compile options, inherit, that's fine, looks good. All right, and then let's click OK. Now, again, here's where the rubber hits the road. I'm just going to go ahead and compile this thing and see what we get. No errors. And hey, look at that. So that's a first pass. That is what it should look like. It is the same data that we saw earlier in here. Let me go back and pull up that sketch. I can get that back. We'll go quickly to that. Review. Yeah, here we go. We'll just use this one right here. Okay, and so you can see the shape is the same. It's identical right there. Okay, so that's good. That worked. Let's do another exercise. This one a little bit different. And this time I'm going to say, so why would we want to do this? Why would we want to ask it to generate a Python script to convert the CSV to SRV? The reason is so that we don't have to come back into ChatGPT or Anthropic or whatever all the time. And if we have a process that is working well, then we can create Python or another kind of script basically as an application that'll help us automate that process. And so let's using the same approach you used, generate a Python script. I'm just going to say reliably. I don't know if that'll make a difference or not. I'm skeptical that this is going to work the first time. But let's get it ready to do that. Okay, so CSV to srv.py import. So there's a library in Python for CSV. There's a reader library. Let's see, input is this, output is that. Let's leave this as is right there. I'm going to make sure that the CSV file does look like this. Actually, you know what? I'm not. I'm going to modify that one, but I'm going to leave this one alone because that's going to throw an error. I mentioned a little bit ago that the file name without the extension can only be a maximum of 8 characters, as can the title in the SRV file. Let's see if that causes an error. And then let's see if we can work with this to fix it. So copying here, bringing VS Code back over, and let's go make a new file. I'm just going to call it data converter. It gave me a name, but it doesn't have to be that. This, yes, I would like to undo that. Let's try that one more time. Data converter.py. And then let me go grab this again, copy, and Control D. There we go. All right, so let's go ahead and make sure. So we're going to make sure that this is actually seeing a CSV file. So we need to make a change there. And we can just come right over here and we see it, morrison.survey. And let's just copy that, come back into here, make this little change like this, Control S, and then we're going to run this, and it claims that it has made an SRV file. Okay, no errors. I was actually expecting some errors. So this is the SRV file that it made. Let's just go ahead and look at it right here, since we're already here. That looks pretty good. I'm skeptical. Like if it did it on this pass, that's like the first time. So let's go clean up everything here in that folder and make sure that we don't have over. I'm going to drag that folder over here so you all can see what we're looking at. So this is the test that we did right here. Okay, and so it obviously has a very different file name. We still have to go through the exercise of creating that project, new project, and over here to 1 terabyte. Demos. I'm just going to call this one test 3. Okay. Okay, all right. And then now we're going to get that survey file that we just generated, and we should see an error. And we do. You've selected a file with a name longer than 8 characters, including extension. This is allowed only for files, et cetera, et cetera. Okay, great. We got an error. That's what we wanted. Now let's just screenshot that. And we're going to give it back to this model and say, got an error. And paste that screenshot in there, basically to see what it's going to do. How to fix it? Just rename the SRV file. Update the Python script optional. Okay, that's fine. We'll just rename the survey file real quick here. And let's just do test 003. Let's bring walls back over. Cancel this, start over again. And we do the test 003. That's the one I picked. 003. All right, and then compile. Oh, it worked. Oh, wow. That actually, okay. And it's the same data that we converted there using Python. So, yeah, so that's it.